Today we're working on section 2.4 on surveys and cardinal numbers. If you're working from your online textbook, you may want to print pages 71, 72, and 73. You also will probably want to have a calculator handy. We're going to begin with number 2. Directions say use the numerals representing cardinalities in the Venn diagram to give the cardinality of each specified set. So again, remember, cardinality is the number of elements. So as we look at number 2, we have five elements that are outside the two circles, 3 that is in A alone. We have 1 element that's shared between A and B, and 7 elements in B alone. So A intersect B, the number in that will be 1. So that's the first answer. Next, we want the number of elements in the union of A and B. So we just want to add 3 plus 1 plus 7. That would give us 11. Next, we want A intersected with B complement. So it's inside A but outside of B. So that would be this part of A. So the answer for that is 3. We're inside A but outside of B. The next one is outside A but inside B. So it's this part of B, which the number of elements would be 7. And finally, we want the intersection of the two complements, so outside A and at the same time outside B. The answer to that would be 5. Okay, now let's move down to number 4. In number 4, we're doing the same thing, except this time we have 3 sets, A, B, and C. You can see the Venn diagram with the number of elements. I've simply copied that from the textbook. And we'll look at number 1, part A, I should say. We want the overlap between all 3 circles. A intersect B intersect C. If we look at this little region right here, I'm going to shade it in yellow. That is where the 3 circles overlap, and we have 1 element in there. Our next step in part B, we want to look at A intersect B intersect C complement. So let's find A intersect B first. All right, I'm going to kind of darken that. There's A intersect B. We want to intersect that with C complement. So we want the part of that that's outside of C. And that would be this little part here that contains the 2. So our answer will be 2. All right, in part C, I'm going to do A intersects C first. A intersects C. Let me outline that in red. All right, there's A intersects C. It has a 4 and a 1 in it. And we want to intersect that with B complement. So we want the part of it that's outside of B. So the part that's outside of B is the part that contains the 4. All right, our next one we want, again, I'm going to start with B intersects C, and then we'll do the complement part. Let's see. Let's go with a dark one. All right, there's B intersects C. Now we want the part of that that is outside A, the complement of A. So that would be, let's see if I can get the color here. That would be the part that's outside of A. So that would give us a 7 for that one. All right, now our next one is we want A complement intersect B complement. So that's everything that's outside of A and B. So that would be everything that's outside these 2 circles. And we want to intersect that with C. So let's see if I can get another color in here. So everything outside of that intersected with C would give us this part of C. So we see we have 5 elements there. All right, our next one, we want to take B complement intersect C complement. So that's everything outside of B and C. Let me get my dark mark here if I can. All right, so here's, all right, the complement of B intersects C is everything outside. Complement of B intersected with the complement of C is everything outside that dark region that I just outlined here. There and all around here. So it's all of this out here. But we want to intersect that with C. So, with A rather. So it's going to end up being this part of A that's outside those 2 circles. So that would be 3 elements. And by same reasoning, we have A complement intersects C complement is going to be everything outside. Let's see if I can outline it in red. These 2 circles. So everything outside of there, but we want to intersect that with B. So we end up with the part of B that's outside there. And I believe that was a 6 before I scribbled through it. And the last region is A complement intersect B complement intersect C complement, which is everything outside the circles. And that is a 10. So that was a little bit tricky, but we made it through. All right, let's move on to our next problem. Now we're working with the cardinal number formula. Let's review what that is. Number in A union B. Number in the union is equal to the number in A plus the number in B minus the number in the intersection. And the reason we subtract that off is those elements are counted as part of A and also as part of B, so they're double counted. So we need to subtract the number in the intersection so that we're not double counting. So in number 6, we're asked to find the number in A union B. So we can just plug these numbers right into the formula. Number in A is 16. Number in B is 28, and the number in the intersection is 5. So we have 16 plus 28 would be 44 minus 5. That would give us 39 elements in the intersection. Okay. Now let's take a look at, I believe it's number 10 that we want to do next. Okay, we're looking this time for the number in B. So again, we're just going to plug in what we know. The number in the intersection is 6. Number in the union is actually what I want to start with. The number in the union is 30. Number in A, what we don't know is the number in B minus the number in the intersection, which is a 6. So what we have right now is 30 equals, if we subtract these two, we get 14 plus the number in B. If we subtract 14 from both sides, we get 16 is the number in B, which is what we were looking for. Okay, now the next group, we're drawing Venn diagrams. And what we're to do, it says draw an appropriate Venn diagram and use the given information to fill in the number of elements in each region. And we're going to start with number 14. We're working in 14, I believe, with 2 circles, A, B, right, just 2 circles, 2 sets. So first step is to draw the Venn diagram. There's set A and set B, and we have our universal set. All right, we know the number in the union. The number in the intersection, that's where we want to start. We always start with the area of most overlap. So we're going to put the 8 in. Number in A is 13, so that means we already have 8. I subtract 8 from 13, that leaves 5. So we now have a total of 13 and 8. A union B has 15. Right now in A union B we only have 13, so that means in this part of B we need 2 more to make a total of 15. And the number in A complement union B complement is, make sure I copied that right, number in A complement union B complement is 11. Okay, so A complement is everything outside of A. So I already have everything outside of A. I already have 2. And then B complement is everything outside of B, and I already have 5 from that, so I've got 7. So that means we would have to have 4 more in the region outside of A and B. Okay, so that was a little bit